So as we continue to talk about quadratic equations, one thing we can find out is that the graphs either have a maximum or a minimum value. And this says that either the vertex is the highest or lowest point of our parabola. So you'll see the difference right here. When a is positive, meaning the number in front of the x squared is positive, we have a minimum, and it opens up. If a is negative, then we have a maximum, and our parabola opens down. So it's real easy to see whether your parabola is going to open up or down, just basically based on the number in front of x squared. So let's look at an example right here. Determine whether the function has a maximum or minimum value. So essentially they're asking us right here in part A, what is the coefficient in front of x squared? Well, since a is -4, that means that it's going to open down. So this is going to have a maximum value. Next one, state the maximum or minimum value of the function. So we said that that max or min is going to be your vertex. So essentially what we're going to have to do is we're going to have to find the axis of symmetry, which is our x-coordinate of our vertex, and then we'll find what y is. So the equation we always did for that was -b over 2a. So in our case, b is 12, so -12 over 2 times -4. So when that's the case, we get -12 over -8, which in turn is a positive 1.5. So now that we know that the x-coordinate is 1.5, I put that back into my quadratic equation. So it'd be -4 times 1.5 squared plus 12 times 1.5 plus 18. I put all of that into my calculator using appropriate parentheses, and I find that I get 27. So what's the value of the vertex? Or the maximum in this case would be 1.5, 27. Finally, the last part, part C, says state the domain and range of the function. So domain is our x values. And so the nice thing is on our parabola, there is no x value that doesn't work. So the domain is all real numbers. The range, however, since it has a maximum of 27, it's going to be that y is everything smaller than 27. So it would be y is less than or equal to 27. Here's a guided practice problem that asks the same questions about this quadratic equation. Determine whether it's maximum or minimum value, what that value is, and finally state the domain and range of the function. Now, here's an example of a real-world equation that has to do with something. Now, it says in your notes, Eddie is organizing a charity tournament. He plans to charge $20 entry fee for each of the 80 players. He recently decided to raise the entry fee by $5, and 5 fewer players entered with the increase. He used the information to determine how many fee increases will maximize the money raised. How much should Eddie charge to maximize the charity income, and what's the maximum value of the pool? So the way we're going to do this is we're going to say, if we look at it kind of in a word problem, the total is equal to the fee times the number of entrants. So what we started with was a $20 entrance fee, and we raised it $5. So every time we raise it, it's going to be another $5. So we'd say that that's going to be 20 plus 5x. And it said originally there was 80 people, but for every $5 increase, there's going to be a 5-person loss. So 80 minus 5x. So our equation then is actually going to just be the multiplication of this. So 20 plus 5x times 80 minus 5x. So what we can do then is we use our order of operations that would say I take 20 times everything in here plus 5x times everything in here. And when I do that, I end up getting, okay, so 20 times 80 is 1600. 20 minus 5x would be minus 100x plus 5 times 80x, which would be 400x. And finally, minus 5x times positive 5x is negative 25x squared. So what's my total equation? 1600 plus 300x minus 25x squared. Now, it kind of looks like a big mess right now. But essentially, what that's saying is that this right here is the equation that will find the total number of people and the total profit based on the number of people and the entrance fee. Now, this isn't in standard form because our x squared is at the end. So if I wanted to move it around, I basically take this one and switch them around, making sure the signs are the same. Well, since this is a positive 1600, and this is a negative 25x squared, it's going to be negative 25x squared plus 300x plus 1600. So that's my equation for profit. Because the coefficient in front of x squared is negative, we know that this has a maximum value, which is good because that's what they're asking about later on. Maximum value, and it's also going to be opening down. So eventually, the number of increases is going to stop and start going down. The profit will be going down. So it asks in the first part, part A, how much should Eddie charge to maximize his income? So essentially what we have to find is what is the x value that is at the maximum. Okay? So we're going to do that by finding x is equal to negative b over 2a. So in our case then, b is 300. So it would be negative 300 over 2 times negative 25, which is negative 300 over negative 50. Divide that out, and you find that x is equal to 6. So it's not $6 is the maximum he should charge, but it's 6 price increases, right? So if we go back to this original part right here, 20 plus 5 times 6. Well, 5 times 6 is 30. So it would be 20 plus 5 times 6, which is 30. So 20 plus 30 is $50. So the maximum he should be charging to maximize his profit is $50. So now that we figured out the price increase to maximize it is 6 price increases, we can figure that out to find out the prize pool. So what we would do then is we'd say, okay, so my x value is 6. And my equation was negative 25x squared plus 300x plus 1600. And so what I'm going to do is I'm going to put 6 in for x. So negative 25 times 6 squared plus 300 times 6 plus 1600. And when I go to my calculator, I put all of that in with appropriate parentheses, and I find I get 2,500. So the maximum amount in the prize pool is going to be $2,500 with a maximum amount of charity income. Here's an example as well. Suppose a different tournament that Eddie organizes has 120 players and the entry fee is $40. Each time he increases the fee by $5, he loses 10 players. Determine what the entry fee should be to maximize the value of the pool. So this part they're really only asking like what we did for part A. So I'll help you set it up right here. Has 120 players and the entry fee is $40. So to find his profit, it's going to be the $40 plus $5 for price change. And we're going to say it starts at 120 players, but he loses 10 for every price change. Now we have it set up. You can go from here. You're trying to find the entry fee. So find x, and then you put it back into this equation right here to find out the entry fee to maximize his profit.